Hi, it's nice to be back. Hey, so this video is all about our next topic, which is all about the angles and triangles. I know you already have your knowledge in angles and triangles, but still, we have to discuss this for a review for our next topics. Okay? So, here are some of the pictures or illustrations of angles. On the upper part and on the left side of the slide, we have here the examples of angles. And on the upper right and the right side and below the slide, we have the different figures of triangles in our everyday life. Okay? So to proceed, let us have the definition of angle. So when we say angle, it is formed by two rays sharing a common endpoint. It contains two rays and a vertex. Okay? So as you have seen on the figure, we have here the two rays and the vertex, or the point of intersection of the two rays, or the common endpoint. So when we say vertex, is the point common to two rays of triangle or two sides of a polygon, because not only the angle has the vertex, also the triangle and the other kinds of polygon that we are going to discuss after 2 weeks. When we say ray, it has one endpoint and goes infinitely in one direction, which we have already discussed about the definition of ray. Okay, so to proceed, let us now have the types of angle. So we have four types of angle. So we have the first one is acute angle. An angle whose measure is greater than 0 degrees but less than 90 degrees. Okay, so I have here 5 figures and you are going to answer the question, which angles are not acute? So again, the definition of acute angle is an angle greater than 0 but less than 90 degrees. So, which are not acute? Which do you think? That's correct. We have angle number 2 and number 5 is correct. Okay? The next type of angle is right angle. Angle that measures 90 degrees. Exactly 90 degrees. Okay? So, from these figures, which angle is a right angle? That's correct. We have number 2. Okay, next. The third type of angles will be the obtuse angle. One angle measures greater than 90 degrees but less than 180 degrees. Okay, from the figures 1 to 5, which angle is an obtuse angle? Which do you think? That's correct. We have number 5. Okay? And for the last type of angle, we have the straight angle. A line that goes infinitely in both directions and measures 180 degrees. Okay? So, which is not a straight angle? Again, which is not a straight angle? That's correct. We have number 2 because number 2 is just a ray. It only goes in one direction. Okay? So, we have the straight angle, or the sample of straight angle is figure 1. Okay? Next, let's now have the triangles and types of triangles. Okay? So, let's have this, the figure. Okay? So, we all know that we get a triangle by joining the three non-collinear points. Okay? So, if you're going to answer the question, what is a triangle? So, it is a closed figure formed by joining three line segments. Okay? So, again, when we say triangle, it is a closed figure formed by joining three line segments. Okay? So, a triangle, of course, has three sides. Okay? So, in this figure, we have side AB. Okay? So, from this part. Okay? And then, we also have side BC. Okay? So, again, we have your side AB, side BC, and the last is side CA. Okay? So, these are the three sides of triangle ABC. And, of course, the triangle has three angles. Okay? So, we have angle ABC. So, we have here. We have triangle BAC. Okay? So, using the vertex A. Then, we have angle ACB. So we have here angle ACB, okay? So as we have noticed, triangle has 3 sides and 3 angles because of the prefix tri. Tri means 3, okay? Next. So let us have now the types of triangles. Okay? So there are 2 ways on how you are going to give the types of triangles. The first is on the basis of angles and the other is on the basis of sides. Okay? So let us now have the how you are going to identify the triangles. Okay? So again, there are 2 ways on how you are going to identify the triangles. We have according to size and according to angles. Okay? So if you are going to name the triangles according to size, so we have isosceles, equilateral, and scalene. According to angles, we have equiangular, right, acute, and obtuse. Okay? So how are we going to differentiate? How are we going to define these types of triangles? Okay? So let's now proceed. But of course, let us take them individually or one by one. So let us have first the types of triangles on the basis of angles. Okay, so how many types of triangles do we have according to angles? Yes, we have 4. So we have here triangle ABC with measures 50 degrees, 60 degrees, and 70 degrees. Okay, so this is an example of acute triangle because it is a triangle whose all the angles are acute. So as you have noticed, we have 50, 60, and 70, which is greater than 0 but less than 90 degrees. So that's why this triangle is an example of acute triangle. Next, let's have here triangle ABC again, but we have the measure 60, 60, and 60. So this is what we call the equiangular triangle because as you have noticed, as you have seen in the figure, it is a triangle whose all the angles are congruent. So when we say congruent, they are equal. So we have here 60, 60, and 60. Okay? Next, let's have this type of triangle. Yes, it is an example of right triangle because it is a triangle in which one of the angle is right angle. Okay, so as you have seen, since we have here this corner which measures 90 degrees, that's why it is an example of right triangle. Okay, how about this one? That's correct. This is the last type of triangle on the basis of angles. So we have here obtuse triangle. Why? Because it is a triangle in which one of the angle is obtuse angle. So as you have seen, we have here 110 degrees. Wherein, when we say obtuse angle, it measures more than 90 degrees, but less than 180 degrees. Okay? So let's now proceed with the property of triangle. So here is the one property of triangle. So we have the sum of all the angles equals 180 degrees. If we are going to add the measure of all the angles of a triangle, that should be equal to 180 degrees. So we have here 60 degrees, 90 degrees on this part of the right angle, then 30 degrees. If we are going to add these 3 angles, okay, the measure of these 3 angles, so we have here 180 degrees. Another example, we have here, okay, 40 degrees, so 90 degrees from this part, okay, right angle, then 50 degrees, and if we're going to add them, so that is also equal to 180 degrees. Another example, we have here 60 plus 60 plus 60 is equal to 180 degrees. Okay? So whatever kind of triangle you may have, that is equal to 180 degrees, or all the measure of the angles will be equal to 180 degrees. Okay? So in this figure, we have given 70 degrees, 70 degrees. What should be the measure of the third angle for you to have the sum of these 3 angles is equal to 180 degrees? What should be the measure of this angle? That's correct. We have here 40 degrees. Correct. So 70 plus 70 plus 40 is 180. Next, let's have here. Yes, we have here 90 degrees because of this part. And then we have here 30 degrees. How about this angle? So what should it be so that you can have the sum of 180 degrees? What should be your answer here? That's correct. So we have here 60 degrees. Okay, next. How about this triangle? We have given 60 degrees, 60 degrees. So what should be the measure of the third angle for you to have 180 degrees? That's correct. So we have here also 60 degrees. Correct. How about this one? So obviously we have 30 degrees, 78. What should be the measure of the third angle for you to have 180? Oh, it seems you have the answer which is not ending in 0, so you have to subtract. Yes, so you have here 72 degrees. Okay, so 72 plus 78 plus 30 is equal to 180. Correct. Okay, how about this one? We have here 40 plus 40 plus blank is equal to 180. What should it be? Yes, that's correct. We have 100 degrees. Okay, any questions so far? Okay, so how about this one? Identify if acute, obtuse, right, or equiangular. Okay, so for number 1, what should it be? Correct. So this is right triangle. Okay, so this is the symbol for triangle. How about number 2? So as you have seen, even without measure given, so we have here 90 degrees. So still, it is an example of right triangle. How about number 3? Obviously, this is an correct obtuse triangle. How about number 4? Yes, we have here equiangular triangle. Why? Because these tick marks means that these three angles have the same measure. Okay? How about the last one? What kind of triangle? Yes, that's correct. We have acute triangle. Okay, any question? Okay, that's good. Okay, so let's work on it using the property of triangles. Again, the property of the triangle is that the sum of the measures of the three angles is equal to 180 degrees. Okay, so I have here 10 questions wherein you are going to determine the measurement of the third angle if the two angles are given. Okay, so we have here 78 and 30 degrees. Okay, so what should be your answer? That's correct. So we have 72 degrees. How about number 2? 45 plus 36. Then subtract the answer from 180 so that you can have your answer. And that should be correct. We have 99 degrees. And how about number 3? 22 plus 98. And then subtract your answer from 180 degrees. So that is correct. We have 60 degrees. How about number 4? 101 plus 52. So 153. Subtract it from 180 or 180 minus 153 is correct. We have 27 degrees. Next, 95 plus 43. So 180 minus 95 plus 43 is correct. 42 degrees. How about number 6? We have 120 plus 18 is 138. So 180 minus 138 is equal to 42 degrees, correct. Next, we have 57 degrees from plus 111 degrees. Okay, your answer will be subtracted from 180 and your answer here is correct, 12 degrees. How about 66 plus 85? And then, subtract it from 180. So your answer is 29 degrees. Okay, how about 19 plus 134? Okay, and then subtract from 180. So you will have 27 degrees. Then 39 plus 91 degrees. That's 130 degrees. 180 minus 130 is equal to 50 degrees. Okay, so I hope you got it. Is there any question? If you don't have, so let's now have the kinds or the types of triangles on the basis of sides. Okay, so we have three types. Okay, so we have the first one is equilateral, followed by isosceles, and the scalene triangle. Okay, so let's have them one by one. When we say equilateral triangle, it is a triangle whose all the sides are of equal length. Okay? So as you have noticed on the figure, we have here 6 centimeters, 6 centimeters, and 6 centimeters. So obviously, we have 3 equal sides. That's why we have here equilateral. Okay? Next, isosceles triangle. Okay, so based on the figure and according to the figure, so when we say isosceles triangle, it is a triangle whose any two sides are of equal measure. So two equal sides is what we call the isosceles triangle. So these two sides are the congruent sides. Okay, so that you can call this triangle isosceles triangle. Okay, next, the last is the scalene triangle. So we have here, scalene triangle is a triangle whose no sides are of equal measure. So there is no equal, or there are no equal sides. Okay, so again, equilateral, 3 sides are equal. Then isosceles, 2 sides are equal. Then scalene, no sides are equal. Okay, so obviously we have here 4 centimeters, 5 centimeters, and 6 centimeters. Okay, so that's why this is an scalene, this is an example of scalene triangle. Okay, so let's identify triangles. Okay, the following slides will show some triangles used in everyday situations. On your paper, identify each triangle using sides, angles, or both. Okay, so let's have this triangle. The red one. Okay, the biggest one. Yes, this is equilateral triangle. How about this one? Okay, sorry. We have here the triangle. This is correct. Isosceles triangle. Okay. Next, we have here, yes, the right triangle. How about this one? Yes, that is acute triangle, or maybe it is also, yes, isosceles triangle. How about this one, or this part rather? You are going to roll out the towel. This is correct, right triangle. Okay. How about the triangle on this part? Yes, that is equilateral triangle. Okay, or also equiangular triangle. Next, how about this Christmas tree? Yes, you have to imagine that that is isosceles triangle. Okay? How about this one? Yes, this is, as you have seen, the number of poles are equal. So this is equiangular and equilateral triangle. Okay? How about this one? Yes, that is isosceles triangle. How about the other one? Yes, that is scalene triangle. Okay? So for our recap, a closed figure formed by joining 3 non-collinear points is called triangle. Correct. A triangle whose all the sides are of equal length is called equilateral. Correct. A triangle whose no sides are of equal length is called scalene. Correct. A triangle whose one angle is 90 degrees is called right. Correct. A triangle whose all the angles are less than 90 degrees is called correct, acute triangles. Okay, and for the last, a triangle whose 2 sides are equal is called correct. We have isosceles triangle. Okay, so for our set work, okay, so let us have here this slide. You are going to identify the triangles on the basis of sides and angles. Okay. So on the basis of size, again, we have equilateral, isosceles, and scalene. On the basis of angles, we have equilateral, or rather, equiangular, acute, right, and obtuse triangles. Okay, so you can answer those kinds or types of triangles. Okay, so I also have here the types of triangles. Okay, so you are going to name each type of triangle But let us just have this orally. Okay, so as you have seen the tick marks, okay, so this will be your hint. So this will be equilateral. Okay, because you are just given the hint that they have or the same measure of the sides. Okay, in number 2, we have, the figure is this. So we have right triangle. Your hint is the right angle. For number 3, we have tick marks here, and then this is not equal to the two other sides. So this is correct isosceles. And no tick marks, no given measure of angle. So this is scalene triangle. Okay, so is there any question? So I hope you can have you gained knowledge about the angles and triangles. So that's all for this day. Thank you and God bless.